Hey everyone, I hope you are doing well. In this video, I'm going to solve a problem that I actually designed myself a while ago. This question is from the topic of limits of trigonometric functions. As you can see, our goal is to find the limit of this big fractional trigonometric expression as x approaches 0. It's pretty obvious that if we plug in 0 directly into this expression, we got this, which we refer to as the 0 over 0 indeterminate form. So to solve this limit, we first need to resolve this indeterminacy. And this means we have to eliminate the factor causing the ambiguity from the numerator and the denominator. Okay, before we start resolving the indeterminacy, we need to go over a few key points. The first point, which can make our job much easier, is to remember this trigonometric identity, which says that the tangent squared of an argument minus the sine squared of the same argument is equal to the product of those two terms. The next 2 points aren't exactly identities. We call them equivalence relations. I mean these 2 points here. Or more specifically in limits, we call them small angle approximations. The first very important equivalence relation tells us that for any power n, as the argument u approaches 0, sine to the n of u, or tangent to the n of u, is equivalent to u itself raised to that same power n. And based on our second equivalence relation, which is also very important and useful, for any power n, as the argument u approaches 0, cosine to the n of u is equivalent to this expression here, 1 minus n times u squared over 2. All right, now we are going to use these concepts to solve our limit. First, I'm going to use our first identity to transform the numerator of the fraction into this form. And as you can see, I did a factorization operation in the denominator. Then, since the arguments of the trigonometric functions in both the numerator and the denominator are approaching 0, I will use our equivalence relations to rewrite the numerator and the denominator like you see here. Okay, now it's clear that the numerator becomes negative 48 times x to the power of 6, and the denominator becomes negative x to the power of 6. And by simplifying the numerator and denominator, the final result will be 48. So, that was another fascinating problem that I wanted to share with you in this video. I hope you enjoyed solving it. See you in the next video.